Gasoline Injection System Service. This video will summarize modern techniques for diagnosing and repairing problems in automotive fuel injection systems. It will demonstrate how to inspect, test, and fix typical troubles. The video will show both single-point and multi-point injector service methods. You will learn to utilize down-to-earth as well as high-tech methods for analyzing gasoline injection system troubles before seeing how to remove and replace major components. By studying typical service and repair procedures, you'll be prepared to follow more detailed service manual instructions when working on any type of car. The first step in troubleshooting an EFI system is to gather information. Talk to the customer if possible. Find out what he or she thinks is wrong with the performance of the engine. Then test drive the car yourself to make your own conclusions about potential problems. Quite often, the customer's description of the symptoms will be vague and even misleading. During the test drive, try to simulate the conditions when the problem occurs. Inspection of the engine and related components will sometimes find trouble sources. Check all hoses, wires, and other visible system parts. Look for gasoline leaks, vacuum leaks, kinked lines, loose electrical connections, and other troubles. With all the plumbing under the hood of a modern car, vacuum leaks have become more common and troublesome to locate. You can use a stethoscope with the metal tip removed to pinpoint the hiss of a leak. Move the tube around any hoses, gaskets, or fittings that might be leaking and making a hissing sound. A vacuum leak detector is a handy tool that works even better than a conventional stethoscope. It uses electronic circuitry and a special test prod to amplify any sounds coming from around the engine and vacuum lines. By moving the prod around potential sources of leaks, it will amplify and allow you to locate leaks more quickly and accurately. Here we have loosened a vacuum hose to show you how the device works. When the probe is moved next to the leak and audible tone is produced, and an indicator light shows that the vacuum leak is present in that area around the engine. Remember that a vacuum leak will affect the performance of the engine, especially at idle, and you would need to correct the source of the leak. After fixing the problem, recheck for leaks. With the metal prod back on the stethoscope, you can listen to the inside of an injector. If a miss indicates that one cylinder in the engine is dead, you can listen to make sure that each injector is firing. An electronic stethoscope provides an even better way to listen to the injectors opening and closing. This unit has large clamps that are attached to the components being tested. The amplifier and speaker will then produce loud sounds to show injector operation. This is a quick way to make sure that a computer pulse is reaching the injector and that the coil inside the injector has not completely failed. In other videos, you learn how to use computer self-diagnosis and scanners to find and correct electrical problems in computer-controlled engine systems. For example, a scanner will quickly indicate failures in a specific circuit. You would then know to test a component in that circuit. This provides a quick and easy way to find electronic components that have failed in an electronic fuel injection system. Large analyzers can also be used to troubleshoot the electronic components in a fuel injection system. Keep in mind when troubleshooting that conventional problems, fouled spark plugs, open spark plug wires, and conventional troubles may seem to be caused by the injection system. In summary, to quickly diagnose electronic fuel injection system troubles, you must have a knowledge of the system, you must know how it is supposed to function, you must use basic troubleshooting skills, which will be demonstrated in this video, and you must use the service manual. The service manual will give you the exact specifications, fuel pressures, flow volumes, and electrical values particular to the specific make and model of car. This graphic shows several potential injector problems. A leaky injector allows gas to drip into the engine with the needle valve closed or the engine off. This richens the mixture and sometimes fouls the spark plugs. Similarly, a dirty injector has deposits around its nozzle. The injector can leak, have a poor spray pattern, or not open and close properly. A broken return spring can make an injector hang up, leak, or not close at all. Injector replacement would normally be needed. Open windings in an injector will prevent injector valve opening. The cylinder will be dead, and an ohm meter will show infinite resistance. Shorted windings will also keep the injector from working. An ohm meter test would show almost zero resistance. A poor connection is a common fault that prevents the computer pulse from reaching the injector. An inspection and meter test of the wiring should find this trouble. If an injector is not firing and clicking, check for computer pulses going to that injector with a high impedance test light. If the test light shows pulses are reaching the inoperative injector, the injector is probably bad. If you suspect clogged or spitting injectors, use an injector tester like this one. It checks the fuel injector by directly observing the volume of fuel injected when triggered by an injector control module. An injector selector and harness assembly allows you to select which injector is being tested. The harness connectors will work on most types of electronic fuel injectors. This tester is unique and very accurate because it fires each injector and measures its fuel output. This is a sight glass. It'll be used to measure how much volume of fuel is injected when each injector is triggered electronically. To connect the tester to a vehicle, disconnect the wires going to the injectors and swing them out of the way. Then, fasten the tester harness wires to the injector terminals. Connect the tester fuel line to the fitting on the fuel rail. Follow specific equipment instructions when connecting the unit. Before testing, make sure there are no fuel leaks. Turn on the ignition key to fill the tester with fuel. Turn the knob on the injector selector to the desired position. Press the test button to fire one of the injectors. As soon as you fire the injector, check the column of fuel on the sight glass. Note its reading. All fuel drops on the sight glass should be the same as you test each injector. A typical variance might be 10% from one injector to the next. Less drop might indicate a plugged or restricted injector. Excess fuel drop might mean a sticking or clogged injector. If the fuel does not hold steady, other problems are indicated. Note that the same amount of fuel is injected in the long and the short pulse positions. The number of pulses is varied, but the amount of fuel injected out of the injector is the same. If an injector is lazy, sluggish, clogged, or sticking, its fuel delivery may be different during long and short pulses. If your performance test indicates possible injector clogging, you may be able to clean the injectors and restore them to satisfactory operation. A cleaning solution is connected to the fuel rail, then the engine is started and operated off the cleaning agent. This will run the solution through the injectors to remove the deposits. This is another type of injector tester. Instead of measuring the actual flow out of each nozzle, it uses a pressure drop as a general method of performance testing the injectors. This type of test will give a general indication of injector condition. If pressure drop is less for one injector, that injector may be clogged and in need of cleaning or replacement. If the pressure drop is more for one injector, that injector may be hanging up and not closing quickly enough. Replacing multi-point injectors is not difficult. Often, small clips hold the injectors on the fuel rail. The clips snap into a groove formed in the body of the injector. When the clip or any clamp in the engine is removed, the injector will pull out of the engine and out of the fuel rail. Always inspect and preferably replace any seals when servicing the injectors to prevent fuel or vacuum leaks. Unbolt the fuel rail from the engine and lift the rail and all the injectors off the engine. Then any injector can be serviced at your bench. When reinstalling the injector clips, rotate the injectors so that the grooved flats are accessible. Then snap the clip into its groove to secure the injector. Position the terminals for easy connection to the wiring harness. Replacing throttle body injectors is slightly different since they mount inside the throttle body housing and not on the engine intake manifold. Note that this type of electrical connector on a TBI unit must be spread open to free it from the injector. This was different from the terminal shown earlier on the single-point injector. With the wiring removed, you can then remove the injector from the throttle body following manual instructions. Many throttle body injectors are held in place by screws. After removing them, light prying will pop the injector out of its mounting hole. Be careful not to damage the injector when prying. Pressing with your fingers, then installing the screws will force the new injector down into place. To check the pressure regulator, fuel pump, and related fuel supply components, measure system fuel pressure. Connect the gauge to the fuel rail, turn on the ignition key to energize the electric fuel pump, then read the pressure gauge and compare to specs. If higher or lower than normal, various troubles may be present. Remember that when you measure pressure, you're actually checking almost everything in the fuel system. A clogged filter, bad fuel pump, leaking fuel line, sucking vacuum, stuck pressure regulator, or smashed return line can all be detected. If pressure is too high or low, or if pressure bleeds off too quickly, it gives you hints about what might be at fault. Typically, TBI systems have lower pressure. Multi-point systems have higher fuel pressure, but remember, always refer to specs for exact values, since the pressures can vary considerably. Before showing you several tricks that you can do to isolate problems, let's review some of the troubles that can occur inside components. Fuel pump problems are fairly common. Worn bushings in a pump will make the motor drag, increasing current draw and pump noise. Shorted windings in a fuel pump will often blow the pump fuse. Open windings will keep the pump from turning on. Bad check valves can allow fuel to drain out of the car's fuel line. This can cause long cranking times or hard starting. Worn brushes can increase current draw and reduce pump volume and pressure slightly. Compare current draw to specs. Poor electrical connections are common. A high resistance between the pump and motor can also reduce pump output. Pressure regulator problems can cause various symptoms. A ruptured diaphragm in the pressure regulator, although not too common, can allow fuel leakage into the vacuum chamber. A weak or broken spring will reduce fuel pressure because too much fuel will return to the tank. A stuck open pressure regulator will reduce pressure even more. Your pressure gauge readings will show fuel pressure way below specs. If stuck closed, fuel pressure can be dangerously high. Your test gauge will show maximum pump pressure and the engine fuel mixture will be richened. A vacuum leak in the line to the pressure regulator is an easy to overlook problem. A clogged tank strainer could cause an engine to stall erratically. If partially clogged, the strainer can occasionally collapse and stop all fuel flow to the engine. This problem will not show up during a pressure test unless the strainer is still collapsed. You would have to measure pressure as soon as the engine stalls. If still collapsed, your pressure readings would be very low. A pressure regulator has the important job of limiting as well as adjusting fuel pressure with changes in engine load. To check the general action of a pressure regulator, remove its vacuum line while the engine is idling. This should affect engine operation slightly. As the vacuum line is removed, it should richen the fuel mixture and affect engine idle speed and idle smoothness. If nothing happens with the line removed, make sure vacuum is being fed to the regulator by feeling for vacuum with your finger. This provides a quick check of the supply line and unit. The service manual will give exact pressure values for specific vacuum levels. If the unit is questionable, measure fuel pressure while using a vacuum gauge pump to check source vacuum at the regulator. The pressure gauge should read a specific level with a specific amount of vacuum applied. If pressure is not correct, other tests are needed to isolate the trouble. Make sure the pump and return line are both okay by blocking flow through the return line. Remove the line and plug it if needed. An easier way to block flow in the fuel return is to install a clamp around any rubber hose. An even easier way is to squeeze any rubber hose in the return line with a pair of pliers. When the return line is restricted, fuel pressure should jump up to maximum fuel pump pressure potential. This eliminates the pressure regulator from the system. If your earlier tests showed low pressure, then this high reading would tell you that the pressure regulator must be shunting too much fuel back to the tank and is defective. To replace a fuel pressure regulator, disconnect the fuel line going to the unit. Then unbolt the pressure regulator from the fuel rail. Make sure fuel pressure has been released before disconnecting any line. To service a throttle body pressure regulator, you sometimes have to remove the throttle body from the engine to access screws from the bottom of the body. This will allow you to lift off and replace the pressure regulator. With other designs, the TBI pressure regulator can be serviced with the throttle body unit on the car. Make sure you have the correct replacement pressure regulator. Throttle body problems can sometimes develop after prolonged service. Throttle body service is needed when surfaces warp, if the throttle shaft wears, or if a gasket fails and begins to leak. A throttle body can have some of the same types of trouble found on carburetors because of their similar construction and operation. When making throttle lever adjustments, remember to always refer to a factory service manual. If screw adjustments are needed, it is critical to use proper methods, since it can affect computer feedback from the throttle position sensor and output to the idle speed control solenoid or motor. To remove a throttle body, disconnect all wires, vacuum hoses, and tubes. Be very careful not to damage hoses and wiring. Remove the fasteners that secure the throttle body to the engine intake manifold. A socket and extension is usually the best way to reach the nuts or bolts holding the throttle body. Before attempting removal, double-check that everything is disconnected and out of the way. Wiggle and pull to free the throttle body from the engine. If vacuum leaks are found before removal, install new gaskets and also use a straight edge to check for surface warpage. When tightening down the throttle body housings, or a large unit like this idle air solenoid, tighten the screws in a crisscross pattern to provide an even clamping action across the sealing surfaces. Replace any vacuum seals with new ones. After making any needed repairs, reinstall the throttle body in reverse order of removal. Install a new body gasket on the engine intake manifold. Make sure the gasket fits on the engine and seals properly. Fit the throttle body into place and torque its hold-down nuts properly to avoid warpage and vacuum leakage. Then connect all other components that fasten to the throttle body. Double-check engine operation after completing installation. Refer to these other videos for more information on fuel injection system operation and service.